Okay, so here is an example in which we will solve this matrix, or in this we will solve these three equations by a Gauss elimination method. So if we convert these three equations in the matrix form, that is 1 1 1 2 3 3 3 3 5, and this vector x1 x2 x3, and in the right hand side we will have 6 17 24. So essentially we are solving this matrix system where matrix A is here and then B is here. So first step is pivot in first row, that is 1. So here is my pivot, and as we can see that this is not equal to 0. So what we will do, we'll apply the row operation and convert all the elements below this pivot as 0. So my row application will be R2 is equal to R2 minus R1 A21 upon A11, and R3 will be R3 minus R1 A31 upon A11. So if I apply these row operations, then my matrix system will become A. This is 1 1 1 0 0, and this becomes 1, this becomes 1, this becomes 0, and this becomes 2, and this becomes 6, this becomes 5, and this becomes 6. So this is my system. Now if we look at it, the second step will be that select this pivot that is in the second row. So this is 1, but if we can see that without doing any row operations, the element below this pivot are already 0, so we don't need to do any row operations further. So essentially, without going to the next row, we have converted this matrix into an upper triangular matrix. So straight away we can do the back substitution, and the back substitution will lead to x3 is equal to 6 by 2 barabar equal to 3, and x2 plus x3 is equal to 5, that means x2 is equal to 2, or then the first row will become x1 plus x2 plus x3 is equal to 6. So we have x1 is equal to 1. Now let me check this out whether this will come out to be 2 or 3. So we are doing R3 minus R1 upon A11, that is, this will be 1 into A31, that is 3. So this will be 2. So this is right, x3 will come out to be 3, x2 will come out to be 2, and x1 will come out to be 1. But remember this, that in this example there is nothing like partial pivoting or complete pivoting, because we did not get that case. In the next example we will see that. So here is that example. So example, that is x1 plus x2 plus x3 is equal to 6, 2x1 plus 2x2 plus 3x3 is equal to 15, and then 3x1 plus 4x2 plus 5x3 is nothing but 26. So my matrix system is 1 1 1 2 2 3 3 4 5, and then x1 x2 x3 is equal to 6 15 26. So for the first part the pivot is 1, and then we do the row operation, that is R2 is equal to R2 minus R1 A21 upon A11, R3 is equal to R3 minus R1 A31 upon A11. So this makes 1 1 1 0 0 0 0 1, and then 0 1 2, x1 x2 x3 is equal to 6 3 8. But when we go to the next step, we will select this as pivot. But remember, pivot cannot be 0. So idea is whenever we have a pivot 0, so either all the element below this pivot should be 0, or we will do the partial pivoting or complete pivoting. So in partial pivoting, or complete pivoting. So let us see what is this. So partial pivoting. What is in the partial pivoting? We will swipe, or we will swap the rows will exchange, or I would call it exchange the rows, and try to make the pivot largest. But these are rows below pivot. Remember that if there are more number of rows below the pivot, that is 0, then we'll try to exchange this row with a row that we get the pivot element as the largest. So we let us say if there are 4 rows and in the second row pivot is 0, then we have the option of swapping it with row 3rd and row 4th. Then we'll change the row, we'll change it with the row when we get the largest pivot. So we had the matrix that is 1 1 1 0 0 1 0 1 2 x1 x2 x3 6 3 8. So we are exchanging these, and then this becomes 1 1 1 0 1 2 0 0 1. This row vector will not change, x1 x2 x3 is not going to change, and this will change 6 8 3. Now we'll further proceed with the pivoting and then row operations, but here in this case we don't need to do that. So we directly get x1 is equal to 3, x2 is equal to 2, and then x1 is equal to 1. So this is partial pivoting, when we are doing the exchange or when we are swiping the rows to make the pivot element non-zero or the diagonal element non-zero. The second part is complete pivoting. In this we exchange the columns. So we had the matrix 1 1 1 0 0 1 0 1 2, x1 x2 x3 is equal to 6 3 8. So what we are doing, we are exchanging the columns. Since this pivot is 0, so we'll exchange this with the column that is ahead in such a way that this pivot becomes largest. So suppose there are 2 columns ahead of this in the right hand side, so we'll change it with the column. Let us say this column is 1 1 2 and the next column is 1 2 1. So we'll change it with this column because here we have 2, and if 2 goes there, that will be the largest. But in this case, since there is only one column in the right hand side, so we will just do this uh, we'll just do this swipe operation. So that will essentially make 1 1 1 0 1 0 0 2 1. But remember, if we swipe the columns, then the vector x will also, this will be x1, this will become x3, this will become x2, but this remains intact. In complete pivoting, B vector does not change. Now we will follow the same procedure, that all the elements below this pivot will be made 0. So we will do that. We'll do that. So let us. So what we have essentially, we have this 1 1 1 0 1 0 0 2 1, and that is x1 x3 x2 is equal to 6 3 8. So what we are doing, r3 is equal to r3 minus r2 a 32 upon a 22. So this makes this 1 1 1 0 1 0 0 0. Here r3 minus, so this is nothing but, this is nothing but 1, since this element is 0, and we have x1 x3 x2, so this becomes 6 3, and this will be r3 minus r2 upon a32 into, so this is nothing but 2, this will come out to be 2. So essentially we have, when we do the back substitution, x2 will become 1, x3 will become 3, and x2 will become 2, x3 will become 3, and x1 is nothing but 1. So we got the same solution. So this is how we do the partial pivoting and complete pivoting. In partial pivoting we swipe the rows, but in complete pivoting we swipe the columns. Remember, when we swipe the rows, then vector x does not change, but vector b changes. But when we do the complete pivoting, so in that we swipe the columns, and in that case vector x changes, but vector b remains same. So remember this thing, complete pivoting and partial pivoting. When do we do these two pivoting? When we have the pivot element as 0, and the element below that pivot, below that 0 pivot element are 0. So suppose we got a pivot element as 0, then we will look that whether all the element below that pivot are 0 or not. If they are 0, then there is no need of doing pivot, partial pivoting or complete pivoting. If any of the element is non-zero, then we will do the partial pivoting or complete pivoting. So this is how Gauss elimination method is completed. In the next video we will study about Gauss-Jordan method. Thank you.